So let's talk about the metric system. Science is done in metric. In fact, most things are done in metric, except in a few small parts of the world. Metric is a base 10 system of measurement, meaning it goes from the numbers 0 to 9, and then it repeats over and over again, 0 to 9, 0 to 9, 0 to 9. This is used around the world. In fact, 98% of the world uses the metric system. And out of the 3 countries that don't use metric system, only one of them is actually a developed nation. So, who here can tell me what country that is? Joseph, you were first. Yep, the US of A is the only developed nation that does not use the metric system. This actually makes it difficult to do business with us. A lot of other nations have to put extra work to do business with the US, and that costs them money and us money and time. It is a bit annoying. I know this because I was talking to a bunch of people who, are into business, and they say that it's difficult sometimes because there are some clients who just won't do it. Now, then there's other people like Almac. Almac is very local. They're a company that's started out in Ireland. And I got to talk to them, and they said everything they do is in metric. They don't have a single imperial measurement in their entire place. Everything is metric. And so I talked to some of their employees, and I said, how long did it take you to adapt to a metric lifestyle? And they said, like a couple days, a week. Like once you actually use it for a bit, it's not a big deal. And I was like, oh, that wasn't quite what I expected to hear. But still, it's pretty good. It also turns out that their factory manager is an old student of mine. That was pretty cool too. All right. Now, again, you got the US. Does anybody know the other 2 countries? One or both? I'm just curious. I will give you a hint. That's a good thing, Joseph. One of the countries was founded by North American slaves who were kicked out of North America and sent back to Africa in a huge movement that happened, I think, right after the Civil War. I didn't think it was before. I thought it was right after. I'll double check the timing on that. But it's an African country that's made of slaves that were shipped out of America. I actually met somebody from that country. He was my student. No one? That is Liberia. Liberia. The African country of Liberia is made of slaves that were kicked out of America and sent to their own nation. I mean, some of them chose to go, some of them didn't. And they are now a country there. And they use all the American systems and whatnot, miles, pounds, and etc. The other country is Myanmar, otherwise known as Burma. Now, the funny thing about that is Myanmar is in the middle of changing back to metric. They dipped their toe in metric, and then they said, let's not do it, and they used their own system. Now they're going back to metric because they want to do business with everybody else. So soon I'm not going to be able to include them on this list, and then it'll be 99% of the world because we're barely hanging on as it is. And maybe one day the US will decide to just use the metric system as well. I don't know. As much as I like my feet and my pounds and all that, I do all my science is definitely in metric. It's almost impossible to do science in imperial easily. Prefixes are the key to metric. All the metric system uses the same set of prefixes. These prefixes are used with every single unit, from the gram to the meter, to the liter, to the mole, to the second, all of them. They determine the strength. Some prefixes are very strong, other prefixes are very weak, but it's always the same ratio every time. And these are multiples of 10. Every prefix that we are going to use is in multiples of 10, and then there are ones and, again, multiples of 10. We'll talk about that soon. All right, so there's that. Now, this here is kind of an overview of metric, and I'm going to dim the light a little bit so that you can see it a little better. But of course, you could always just follow along on, since this is already posted. Now I'm curious if you know some of this. Now you can see with this, it gives you what the measurement is, what that actually means, and then we're going to do the base unit and the abbreviation. So it starts with mass. Mass is how much stuff makes up an object. If something has a lot of mass, they have a lot of stuff. That stuff is atoms and molecules, but stuff. All right? Now, in metric, the unit for mass is the gram. And the abbreviation is a little g. So do you see how this goes? Now, when this is done, if you want to take a picture of this, cool. If you just want to go online and look at this, cool. I don't care. I'll emphasize a few things you really should have and write down, but that's about it. Now, I would like to know if you know the metric unit for volume, which is how much space something occupies. Francis, could you tell me, if you know, what is the base unit for volume in metric? No, that's okay. I mean, that's part of what we're doing here. Does anybody know the base unit for volume in metric? Now, this one has infected America a little bit because if you buy carbonated beverages, they're typically sold in this unit. All right? Want to give it a go, Joseph? It is the liter. Very good. So those are the liters. Now, Francis, just to poke you one quick time, do you know the abbreviation for liters? It's one letter. Yes, capital or lowercase? What do you think? All right, that is a common misperception, but it is actually a capital. But that's okay. Now, the thing is, a milliliter, which is the most often used form of liter, is often put as little m, little l. That is actually a mistake, but it's such a hugely done mistake that happens all the time. Scientists have given up correcting people. At this point, they've just accepted it. I disagree. I like it little m, big L, but I'm going to go with the flow too on this one. I'm not going to mark you wrong for some reason. It is now accepted. All right, distance, the space between 2 points. Ashton, what do you think? Yeah, what's the unit in metric? It's not a foot, it's not an inch, it's not a yard. What do you think it is? You don't know? That's okay. You'll learn now. Does anybody know what it is? All right. Good, Joseph. Meters. Is the what? Meters. It is the meter. Very good. All right, so Ashton, what is the abbreviation for meter? Capital M? Lowercase m. Very good. It's definitely a lowercase m. All right, now this one might be a bit easier. Temperature. A lot of people seem to get this one. Ms. DiMarzio, what do you think? Very good. Now, we technically call it degrees Celsius, but that's okay. You can call it Celsius centigrade. I wouldn't ever care. All right, do you know the abbreviation for it? Yes, it is, and it has the little circle in the upper corner. Now, real quick, the reason this is degrees Celsius is because back when Celsius was first built, same with Fahrenheit, the tools were new. They were stuff that they had developed, and as such, they weren't super confident. And so they said this is degrees Celsius as opposed to 1 Celsius. Now, we've gotten better, we have better tools, and at this point, it's a little more standard. And that's why Kelvin, which is the newest form of temperature, is not degrees Kelvin, it's just kelvins, because we have the tools to measure it better. Now, you can still trust degrees Celsius, you can still trust degrees Fahrenheit, it's just that's why it's degrees. And in this class, if you say that something's in degrees Kelvin, I'm fine. I don't really care that much. You can put all your temperatures in degrees as far as I care. But that's the history of it, and I thought you should know. Okay, so then we get to quantity. Now, quantity is tricky, and quantity is very particular to chemistry. Does anybody know or think they know what the unit for quantity is? This is for atoms and molecules. And this is a really tough one, so I understand if you don't know it. Okay, we're going to have a whole chapter on it. It's called the mole. The mole. M-O-L-E. And the abbreviation is M-O-L, all lowercase. This is going to be our chapter 4. Chapter 4 is all going to be about the mole. It is the most useful unit chemistry has because it connects everything. Now, time. Time is a little more manageable. Miss Fitzhenry, what do you think the metric unit for time is? It is pretty simple. It's not, I'm not trying to trick you. This is an easy unit. You have probably used it. It's the same as an imperial. Yeah, but what's the smallest one that we use? Very good. The base unit is seconds. Absolutely correct. And yeah, we use minutes and we use hours too, but the base unit is considered to be seconds. Very good. Now you can represent that with a lowercase s or a lowercase sec. Both of those are acceptable. Both of them are used in various parts of the world. All right. Now, pressure. There is lots and lots of units for pressure. We are going to primarily use the atmosphere, which is little atm. We're going to do a lot of this in chapter 6. That brings us to energy. So there we go. Now, the really big and the really small. You got your really bigs to the left, your really smalls to the right. A mega is equal to 10 to the 6, or a million of them. Its reverse is the micro, where it takes a million of them to equal 1 of your base unit. So a microliter means you will need a million of them to make a single liter. So that's pretty small. Giga and nano are 10 to the 9th. Tera and pico are 10 to the 12th. So whether you need a million, a billion, or a trillion, these are your expanded metrics. Now, if you're into technology, the mega, the giga, and the tera, you've seen those. Anything like a thumb drive, where you have a megabytes, gigabytes, terabytes. When you're dealing with high-end science, you've got micro, nano, and pico. That's talking about how big something is in many cases. A picometer is something that I've used a fair number of times, where it measures things in picometers, where super, super tiny amounts or super, super tiny distances. They do that for waves like light. So it's kind of neat. They also do a lot of light with nanometers. So those are your extra metric prefixes. Okay, this here I made because I don't think a lot of people understand the strength of these various things. Like, how big is a gram? So I made this to help explain that. Again, this is something you can take a photo of or something that you can write down. But there's a couple of things I'm going to emphasize, and I really want you to write those down in your notes. First off, a gram is about a small paper clip or a pen cap. So the amount of stuff that's in a small paper clip or a pen cap, that's a gram. Not a lot at all. It's pretty bloody light. Now, for a milliliter is 20 drops of water. But this is where you've got the first thing that I really, really want you to write something down on. And that's this. I want you to write down, and of course I messed that up, so let me try that again. That 1 milliliter is equal to a centimeter cubed. That's a really important idea for you to know. Milliliters and centimeter cubes are interchangeable. So you should totally write that down. That is the definition of a milliliter. It's a centimeter by a centimeter by a centimeter. Length, width, height. 3 dimensions. You now have a milliliter. So that's why I have that there for you. So please write that down. It is very useful. Now, how far light travels is a meter, and that's about a yard or 1/100th of a football field. It's a little easier to realize that if you're into sports or if you've ever done things like building. Celsius, about 1 Celsius is about 1.8 Fahrenheit. It starts at different places, but 1 degree Celsius is about 1.8 Fahrenheit. Moles is about half a cup of most dry chemicals, which is something you could hold in the palm of your hand. So take your hand, stretch it out, cup it out like this, and imagine you had salt in your hand there. That's about a mole. Do you see how that is? It's not a lot, but that's about a mole. All right. Now, an atmosphere is about 30 feet of water pressure. So an atmosphere is literally the entire atmosphere pushing down on a single, a single square centimeter, I think it is, through the entirety of the atmosphere, which is about equal to 30 feet of water. So if you've ever gone in a deep dive pool and you've dived all the way down for 30 feet and you feel that weight above you, yeah, that's an atmosphere. A lot of people who do that, by the way, they actually feel kind of normal because that's about what you get if you just walk outside. So it's not really like crushing because it's something you're used to. So, but it's odd. If you go below that, that's when it gets very uncomfortable. Now, joules are amazing because they connect so many metric units. A joule connects so much of this, which is why Metric is great for doing energy problems, which is our 7th chapter, which we could not do in the imperial standard easily at all. You guys would hate me if I ever made you do that. So we're going to do joule, which is way easier. Now, a joule is very light. A candle flame, like a little birthday candle flame, is about 33 joules per second. So joules are an incredibly small unit of energy, but it's very useful because it connects so much else in metric. So that is kind of a little like preview or highlight reel of the metric system.